So let's pass to the last poster presentation. The following work is entitled Evaluation of Technological Contributions to the New Copper-Based Fungicides, work done by Cristiana Paiva. And Cristiana, that comes from the GreenUPorto, if I'm from GreenUPorto in Portugal. So Cristiana, the floor is yours.
So good afternoon, everybody. Thank you so much. I'll share my screen. I hope that you can see it.
Sure.
Yes. So today I'm bringing you a work that we developed as a multidisciplinary team at GreenUPorto with the help of chemists and also from geosciences. So this work was about the evaluation of technological contributions to new copper-based fungicides. So we are currently assisting to a great contribution of new technological developments that are allowing the production of new formulations of pesticides. And today I will be specifically talking about these contributions to the development of new copper-based fungicides. So currently reducing the copper environmental inputs while maintaining crop protection is considered an urgent need. And one of the solutions that has been brought consists in reducing the particle size of these formulations. So formulations with copper particles that are reduced in size, and this will give these formulations a larger surface area. So a lot more copper ions will be released in a more efficient way. And this way we have more antimycotic activity with less percentual copper in the formulation itself. So, but why is it important to reduce copper environmental inputs? So, due to the copper persistent nature as a metal in the environment, there are concerns about copper accumulation in soils and the negative outcomes that comes with it. So right now, the European Commission is imposing restrictions in copper use. However, we still have the same necessity of treatments. And this question is even more relevant when we talk about organic viticulture, because there's a highly dependence of copper-based fungicides to treat certain infections that bring a high impact to the yields of this sector, and there is no other alternative to copper-based fungicides since synthetic organic fungicides aren't allowed in organic viticulture production method. So this being said, this work focused mainly on the characterization of one traditional copper hydroxide formulation and two new formulations that are already available and are allowed for its use in Portugal for organic agriculture in order to understand how they differ in their particle size, composition, and also their dissolution. So in here, I bring you some information about the formulations that we have chosen. And you can see that the main difference between these three formulations is their copper content. So these are the two new formulations that have a substantially lower copper contents when compared to the traditional one. However, the recommended doses for application in vineyards remains pretty much the same. So what happens here is that the producers of these new formulations rely on a new technology that it's patent and they call the bioactive technology, which whilst we don't have access to the information on how they are produced, we know that they count on smaller particles of copper to have a higher acute effect of copper, but also they promote the slow release of copper for a prolongated action of these fungicides. So we were interested in assessing the particle size of bulk formulations. So whilst these formulations are in the powder form, and we did this with the use of SEM. We also were interested in assessing the particle size of dissolved formulations because these formulations are applied when they are dissolved in water. And we did that by using dynamic light scattering. And also we did the composition analysis while recurring to 3 different methods of analysis. And in here you can see the appearance of the 3 formulations, the traditional one and the 2 new ones. So regarding the results that we obtained, in here I present you the results that we were able to extract from our analysis with SAM. And far more relevant than the pictures, we were able to measure the size of these particles in the powder form. And one thing really interesting to know is that these formulations, the traditional one had the smaller particle size when in powder compared to the 2 new formulations. However, this changes when we dissolve the formulations in water, and these are the results that we obtained for dynamic light scattering. And in here, we can in fact see that the 2 new formulations are substantially smaller particles when compared to the traditional one. Another thing that we could tell was that these new formulations, when they are dissolved in water, are able to produce a final product that is a lot more homogeneous in the terms of size of particles when compared to the traditional formulation. And another thing that we could tell that is really interesting is that the traditional formulation tends to have a lot more aggregation of its particles. So in this case, with the traditional formulation, the release of ion coppers can be smaller when compared to these new formulations because the aggregation isn't promoted and the final product remains the same. Regarding the composition analysis, with SAM, we were capable to see that only in these new formulations we have the presence of carbon. And this seems to tell us one thing, that these new formulations are taking advantage of the use of carbon-based polymers to produce a slow release of copper through time. So these polymers are used to retain a lot of copper particles at the same time, and these copper ions will be released through time. And regarding the quantification of other metals and other trace elements, we could actually see that the new formulations have a higher concentration of other metals and also other trace elements that sometimes aren't even found in the traditional formulation. And this tells us one thing that can be really interesting and not exactly about the contribution of these elements to the efficiency of or toxicity of these formulations, but actually that these new formulations are produced using another formulants, okay, that are bringing other components into the final formulation. So we could see that by manipulating the particle size, the co-formulants used, and also the elemental composition, we can have a final product that is still a copper hydroxide based product that can exert efficiency different from its traditional components, the traditional formulation. However, it's also important to note that by manipulating all these factors at the end, we can also have different toxicity of copper to non-target organisms. So this is relevant when we want to assess environmental outcomes of the use of these new formulations. Thank you for your attention.
Thank you very much, Cristiana, for this presentation. Let's move to the time of questions. Does anybody from the audience any question to Cristiana? Well, let me just make a comment because it's not my research field, so I'm very, very far away from that things. But that's nice to see that sometimes because I understand that the 3 pesticides that you are analyzing are commercial ones,
Yes,
are commercial formulas. So that sometimes when new formulas appears, they say that we have low values of copper, that it's one of the problems of using pesticides. It seems that we solve one problem, putting into another one, because we change the formula, so we include new elements that we don't know how will affect to the environment. So that's nice having this kind of studies that shows that probably trying to solve one thing, we are complicating another one.
Yes, at the end, they are available and are commercialized and even allowed in organic agriculture because, in fact, they are a copper-based fungicide, right? But we can see they have a lot of different features from the traditional one, and they require another analysis of how they behave in the environment when they are applied. Yes.
And nowadays they don't provide anything regarding this. So it's only
Yeah.
based on the copper effect, but not on the new.
Yes.
Okay, okay. So good work. Congratulations for this presentation. Manon also saying, very interesting subject to work on. The questions around the use of copper are also raised in France.
Yes, because in France they have a high mildew pressure, so they are highly dependent on these copper-based fungicides. So it's also a problem. Yes.
Okay, any other common question? It seems that not. So again, Cristiana, thank you for your presentation and for joining us in our workshop. Congratulations. Well, and also congratulate all the presenters in this afternoon session, this last session of our workshop.